Hello, hello, it's Brian from Tavaran Games here with episode 9 in our strategy map generator tutorial series. Now in this episode, I want to cover getting the user interface made for our map generator, where we can control all of the different parameters using these sliders, as well as having a couple different presets that we can use when we're generating a map. And then hopefully we'll have time to go into a couple other smaller things, like adding in the path preview for units as they pathfind, as well as spawning those units in and maybe spawning some resources. Okay, so let's jump back into our tutorial where we left it. And the first thing we're going to do, we're going to need to go to our canvas element, and we're going to be adding in a UI, just an image is what I'll use. Now, at the moment, our image is going to stay blank white. We're going to make it fill a good chunk of the screen, and we're going to go into here. So we're going to call this our generate menu, and then inside of that we are going to add in more UI. So first let's just make some title text so we know what the menu is. Center that text, center this, and then this is going to be our title, so the map generator. Let's just make this bigger text. Okay, and then for all of this we're going to want to be changing the names just so it's very clear what's in here. So we're going to add some more text, pop this over here, let's just make it look like what it's supposed to. So this one is going to be the size value, and we're going to call this map size, or change the text to that. So let's pull this over here, and now as a child of that, let's add in a UI element of a slider. So Unity's got this built-in default slider as part of its UI. Come on, that's where I want you, perfect. And we can set the values. So for the map size, what I want to use is value, oh yeah, I can't have that, 2 to 5, and then use whole numbers only, because what I'm going to want to do is I'm going to make the map height equal to 10 times whatever this value is. Okay, so this is going to be the size slider. Okay, so we have our map size. Let's just copy that and bring it down. So we're going to want the number of masses, so islands, actually we'll call this masses here, and so here we're going to say number of islands, we'll call it that because that's clear for what it's supposed to be. And then for that one, let's do value from 1 to 5 for now, and we can change these later. So let's set the defaults here as well. Let's do that. So the other things we can change is the size of the islands. So this is going to be sizes, and then this is going to be island sizes. And so that's the grow function from before in the hex tile. Again, we can leave that from 1 to 5 as integer values is fine. The other option we had was that what I call the porosity. So that's the frequency value when we're doing our hexagon growth of how many of the surrounding tiles does it try to convert. And we're going to want to set this also 1 to 5, and that one we can just leave. Now, the way I described it here is internal density. So that's how dense the islands are. And so the higher this number, the more dense they should be. And then let's make one more in this section, which is that clustering we set up to generate different islands and continents. So we're going to call this one mass shapes maybe. We'll just call it that for now. Okay, so those are our main values. And again, these are all 1 to 5, and then the map size I made 2 to 5. And then we have our floats. So that's, if we go back to our tutorial, that's our desert frequency, grass, hill, tree frequency, mountain frequency. So we're going to want to set those as well. So let's copy and paste this. Put a little bit of a gap for now. Okay, so this one's going to be our, let's start with the deserts. And here, deserts. And then what we actually want for the values, because that's a frequency from 0 to 1, and then we can get rid of the whole numbers. And then let's set the default to 0.5, right in the middle. So we need a bunch more of these. So all the default values are just going to be 0.5 for all of these, but that is okay to start. All right, so we have our menus here. The other thing we need in our UI itself, in the generate menu, are a couple of buttons under UI and then button. So let's drag one down. This is going to be our cancel button. And then we need to go over here and change its text. And then we are going to want a second button for confirm when we actually want to do it. And again, change its text from cancel to confirm. Okay, so we have our basic here. And now let's go to our actual text in order to be able to use that. So in our interface here, we're going to have a game object for our actual menu itself. That can be a game object. And then we're already using the Unity Engine UI. If you haven't put that in, you need it. So we're going to want our sliders. So we do a public slider, and we got a bunch of them. So let's just, the way I write this, go down the line. So we have the map size slider, comma, and then we have the mass is, or let's just call it mass slide. And then semicolon that. And then we have our buttons. So we have cancel and confirm. Okay, so on here, we no longer want the generate button to actually generate, because we want that to be on the confirm button. So we'll need a new void called open menu. Open menu. So this one, it's super simple. We're just going to get the gen menu dot get component. And we want its rect transform, because that's what our UI elements use. And then we want the anchored position 3D. We will set it in 3D space. If you do not, its Z value can sometimes become a very high number that's outside the clipping plane of the camera, and suddenly your menu's not visible. So we'll just set that to 0, 0, 0. That's going to be the center of our screen. And now we want a close menu. And then that's going to be the same thing, except we're going to make it so the coordinates are off the screen. So put this here, and let's just set the Y value to a few thousand. And that way, it just gets shot up off the screen to where we can't see it. So we're going to do our cancel is going to get an on-click as well, and add listener, close menu. And then for our confirm, we are going to do an on-click dot add listener. This is going to be generate. Finally, this is where we do our generate from. Okay, and now we want to go to the bottom in our draw grid. After we draw the grid, we can call close menu here so that we remove the menu after the map is drawn. Okay, so in our generate function, this is where we're going to do our calculations for what each of those slider values translates to. So the first thing is going to be the map size. So the map size dot y is what's going to be set by our slider. So we're going to round to int just to make sure it is an integer value. So I'm going to do 10 times the size slide dot value. Okie dokie. Now we're going to want our map size dot x, and that is going to be our map size dot y multiplied by 2.5. So that's just my numbers. You can make these whatever you want. You can make the map ratios anything. I like 2.5. I think it looks pretty nice on a standard 16:9 resolution monitor. Okay, so the next thing we have to figure out is how our masses are calculated from our mass size. So that's how many starting island masses we have. So the actual value for that we called masses. Now, the equation I ended up coming up with, so we do our mathf, we're going to seal to int, so we're going to round it up. And we're going to take the map size dot y, multiply that by 0.4f, and then we're going to multiply that by masses slide, or mass slide, yep, dot value. And then what I did is I added to that another integer, and that's going to be 5 minus our size slide dot value. And I found that this generates a good number of land masses for how large the map size is set to. Because again, our map size dot y is going to be between 20 and 50. So multiplying by this ends up giving us a decent number of starting masses. And then adding on this little bit of extra based on the map size gives us sort of a nice minimum as well. So I played around with a few different equations, and that's one I ended up liking. Now, I want to actually round this up to an even number. So we're going to check if the masses calculated remainder of 2 is equal to 1. And if it is, we're going to add 1 to it. So this way, when we do our clustering and we divide by 2, we end up with a nice clean round value for each number. Okay, we have that. So let's get our island sizes. So we're going to first set a minimum size. We're going to calculate it as an integer. And then on this, we're going to ceiling again. So ceil to int. And now we have our size is slide dot value. So that's between 1 and 5. We're going to square that. And we're going to divide that by 1.8f. We're going to try that for now. I found that that has worked in my previous code. And now we need to set that into our island sizes. What did we call that? It's been a little while. So we go up here. We just called that grow. Okay. So grow is going to be equal to a new vector 2, and that's going to be the size min we just calculated. So we're going to take that size min. Our second number does have to be larger than the first, and then we're going to round to int our size slide, so our map size, divided by 2. So this way, larger maps are going to have more variation in the individual island size than smaller maps, since we have a lot more real estate to work with. Okay, so the other value we have is that porosity, which is our frequency value. So we just have to set frequency is going to be equal to that por slide dot value. Now it's an integer, so this will complain. So cast that to an integer. Okay, so we've set that, and now we need to calculate our clustering value. So our cluster is equal to, we're going to start as our number of masses. Now, if our clustering is greater than 1 at this point, our cluster slide dot value is greater than 1. We're going to set our cluster equal to mathf dot ceil to int. We're going to round up on these because we need it to always be greater than 1. So we're going to take our number of masses and we're going to divide it by our cluster slide dot value. Dot value. We're going to multiply that by 2, and then we're going to subtract 2 from that. And now what we need is to check if it's equal to 5. So if cluster slide. So this is the maximum value we set. So if that's equal to 5, we then want to basically make the cluster equal to 1. So this means it's 1 island per, and then this has to be dot value. Okay, so our clustering has been set. Now our mountain, desert, grass frequencies, those are all, as we know when we look at it, they're basically values between 0 and 1 up here. So we can just set those directly since that's what we made the sliders. So des frequency is going to be equal to desert slide dot value, and then the same thing is going to be true for our grass, mountains, hills, forests. Okay, so we're grabbing all the values we have in that menu, and then we are applying them. So let's go back into our tutorial screen. We have our generate menu here. Let's go to our camera though, and then here we're going to drag everything over. So this will just be the boring part. Drag all those over. Now let's grab this menu and let's just pull it off the screen so that it's not visible on game start, and let's save this. Now let's see if those sliders actually do anything. So this is with the default values. This is the map it generates. So we'll hit the generate, that pops up. So we'll keep the map size at 2. Let's do a large number of islands using small. And then our mass shapes, let's set that to 5. So that's completely separate islands. And let's try what low density looks like. Okay, so it definitely generated something a bit funky. Now, if we turn the sizes up and that up, confirm, and we get these larger islands. If we set this over here, that should be set to 2 right now, which is going to be that 2 continents. Good, so that generated. Let's do max island sizes, max density, and we should get, 2 big land masses that actually grew into each other. We can test these other bits, so lots of desert, lots of grassland, lots of mountains, hills, forests, maximize all those. And yep, you can see we have just way too many hills, lots of desert and grassland. And and then tons of mountains. So that is all looking like it is working. So let's turn these all off. And yep, we get none of those features. Okay, so all of our sliders are working. We now have to figure out what are our presets going to look like. Okay, so for that, we have a few different presets we can create, and you can make as many as you want. So let's actually just grab these guys and pull them down a bit. Let's just make some room for some buttons. The way I liked to, or where I like to place this, was down here, and we're going to use buttons. So we're going to set this. This one's going to be small islands. Now on this, we're going to change its name, or its text. And then we want to make this a little bit narrower, because we don't need it to be that big. So 1, 2, I'm going to do small islands, large islands, continents, and Pangea. And we're running out of space. That's okay. This is, again, you can make all this pretty later. Now, fortunately, with these guys, what they do is all pretty easy. They're just going to change the sliders values here, and we can do that in our code. But first, we need to add those to our buttons. So we know we have small isle, we have large isle, continents. Let's spell that right. And then Pangea. So these are all of the values we have now. Excuse me. You can make these whatever you like. You can do different ones. It is all up to you. These are ones that I just thought of. And then we need some voids functions to actually set these. Set islands 1. This is going to be our small islands. So the values we want, we don't want to change the map size. What we want to change is our masses. So the mass slide dot value. We're going to make this one fairly high because we want lots of different islands. But then we want the islands themselves to be small. So size is slide dot value is going to be equal to, let's set that to 2 out of 5. The clustering we want to be equal to 5 because that means that they're all individual islands. We're not we're generating each thing in its own individual little box. And then our porosity slide, its value is going to be equal to 2. We want these to stay fairly small. So we want our sizes and porosity to be somewhat small, our clustering to be the maximum at 5, and then a lot of islands. Okay, so that's going to be our small islands. Our large islands, we'll just do this as 2. And then at this point, it's a little bit easier. You just play around with the sliders to find the numbers you like for each preset, and then you just set them in here. So for larger islands, we want fewer masses that are, again, separate clustering, but we want each mass to be larger. Okay? And then we can do continents as our third preset. And then for the continents, we do want a lot of masses. The big difference we want is we want larger masses that grow into each other, but we want to set the clustering to 2, and let's set the porosity to 4. And as I said, I found these numbers by literally sitting down and just trying a bunch of different values until I got ones that I liked. And then for Pangea, our clustering is going to be equal to 1. That is our completely random clustering. So all of the masses are placed into one centralized box. And then we're going to want to put a lot of land in it. So we're going to do 5, 5, and 5 for all the other values. So that should fill it out. So we need to trigger those. So we're going to use the same type of thing, the onClicks. So small island dot onClick dot add listener, and this is going to be set islands 1. And then just copy and paste this for the other settings. Okay, so we have our large islands, and then this is going to be set islands 2, and then continents is going to be our set continents. Continents, okay. And then this last one is Pangea. So we're going to save that. Let's go back into our tutorial. Okay, so we need to go to our main camera so that we have the buttons over here, and let's just drag them over. So our small island, our large island, our continents, and our Pangea. So let's save that. Let's actually make this box a little bigger so that they fit in nicely. And again, save that. And let's see what those buttons do, if anything. Okay, so again, these are what our default values generate. So when we hit this, we should see these sliders change. So let's start with Pangea. And you can see we get one landmass that fills most of its area, and then an ocean on the side. Perfect. Let's do that again. And again, same thing, a new landmass. Continents, so we do that. We end up with two separate large continents. Let's make it even bigger. So let's generate a huge map. And again, it still fills the screen nicely. We do continents on a small map, and we get about the right amount of landmass. Okay, so let's try our large islands, see what that looks like. And we have more larger separate islands with some gaps between. I really like this map. That's pretty cool. And then finally, small islands, and see what that looks like. Yeah, so we might want to change those values a little bit. The islands are a little bit small, but you get the idea. And again, you can play around with those values and develop whatever you want. But now you have an interface that you could present to your players in the map or when they're creating a game, and they could set the values they want for how they want the map to look. Okay, so that's not too difficult, and we have it pretty much in place and done. Okay, so the next thing we can cover, let's grab our scout and let's put him as a resource so we can spawn the scout on an applicable tile instead of just having one on the screen. So now that he's in the resource folder, we can delete the one on a screen. Let's go to our tutorial. And then when we do the draw grid, we can use this to also spawn our unit. And it's not going to be too difficult. All we have to do is tell it how many units we want to spawn. So I'm going to call that placed, and we're going to, or how many we've placed. We also, of course, want, as always, to track our attempts because we're going to use a while loop. And then we're just going to use, as I said, a small loop. So placed is less than, let's just try to place 3 guys. And then we don't want it to take too many attempts. Let's say it'll take a maximum of 100 attempts. I mean, it should place them well before then. So as always, plus equals to 1 on our attempts. And now we want to generate a random position on the map. So vector2 position is going to be new vector2 mathf dot round to int. And then inside that, we're just going to do a random dot value times yeah, it's map size dot x, and then same thing in the y, except map size dot y. So that'll give us a random location. So we now want to raycast to that position. So raycast hit 2D is hit is equal to physics 2D 2D dot raycast. And this one we're going to do pause 0 and layer mask dot get mask, and then we're going to look at our default layer again. That is where our tiles are. They're nowhere else. Okay, so we do our raycast, finish that, see if we hit a tile. We should hit a tile every time because we're within the map bounds. However, because we're rounding off our map size integer, we're going to get 0 to the map size. That might be higher than 1. So, actually, let's correct that now. So this way we end up with something that's truly inside of our map. There we go. Now we have a random value between 0 and our actual width of the map. Okay, so we need to see if we actually hit a tile and not something else, even though it should be a tile. So we can just do a name.contains look, and we know that they're called hex. So if that's contained in the name, we know we have hit one. And now we're going to do another if statement because we're going to check the type of tile we've hit. So dot game object, we're going to want to do dot get component. And in this case, it's our hex type, which we've wrote a very long time ago at this point. And we're going to check the type. So we have to make sure is not equal to 0 and that it's not equal to 4. So that way we're avoiding our oceans and we're avoiding our mountains. We don't want our units spawning on either of those places. And now that we have that, we can instantiate our scout. So we want to instantiate a resource as a resources.load because it's in the resource folder. And in this case, it is the scout. That's what we've named it. And we're going to do it at the position of our hit collider. And we're going to make it a child of that object. So transform.position for our position. And then we don't want it to rotate, so we're just going to go quaternion.identity. So that's its default rotation. And then hit.collider.gameout.transform is going to be our parent. And then we, of course, have placed one, so place plus equals to 1. Apologies for clearing my throat. I have some allergies going on right now. Okay, so let's save this, and let's see if our little scouts actually show up on the map. And then we have one up there, one there, and then one down here. So we got 3 little scouts we can click on. We can pathfind, and they should start moving. This guy can pathfind. And then this one over here. Let's have them all moving at once. Alright. So we have our little units. They've spawned in. Great. Okay, so let's do our pathfinding preview for those units. Now, the thing we're going to use is going to be a sprite shape. So if you go into the window and open up your package manager, you should have a 2D sprite shape as an installed package. If not, you're going to want to search for that and install it. Now, in our code, it's like with the UI, where we need to actually call that we're using it as a class. So this is under the Unity engine, and then it's .u2d. So Unity 2D, all capitals. And that's going to let us do a sprite shape. Oh, I'm in the wrong script. We shouldn't be in the map maker. This is going to be in our unit control. And then also in our controls control, I believe. Yep. So the actual game object, let's make that. Okay, so we're going to go here. We're going to close this. Under our scout, let's open them up. And then we're going to add in a child object. It's going to be a 2D sprite shape. Okay, so that's a new sprite shape controller. And now we have to make this not look terrible. We need to first set or change our spline. So you can see a sprite shapes is a box. It's whatever shape it wants to be. You just set these points, and as you move them, it's going to fill in that area. So what we want, though, we want open-ended. So that way we can basically make a line with a start point and an end point. We're just going to give it some weird default values just so we can actually see it. So under the edit spline, it doesn't matter because we're going to use code to edit this. Okay, so we're going to call this our path preview. And now you can see, though, if we deselect it, it's a very thin line. Actually, it's not even visible if we don't have this our guy selected. Well, that's because we actually need a sprite shape texture for it. Where is it? Now, in a sprite shape profile, we're going to do a open shape. So this is our sprite shape. Now, the texture, we're just going to set it to UI sprite. It's going to look a little funny. No offset. Let's go back here, set the path preview, and let's give it its profile. And it's complaining. So the new sprite shape profile. So as we go around, it should be filling in. And then, oh yeah, let's give it a sprite here. There we go. So if we give it a sprite on the angle, we then have this guy, and it's a funky little line, and that's okay. It doesn't need to look perfect now. You can play around with that and make the image. But let's make it slightly transparent, so around 150 or so looks fine. Okay, so we have our sprite shape profile here called path preview. So what we're going to want to do is, in our code, we're going to want to set the coordinates for the path preview. So we're going to go over to our unit control. We have the UTD set from before. So we're going to need a public sprite shape controller, and we'll call that the path line. So that's got to be public. Now, we're also going to want its list of locations where we actually want to go. And we're going to want to set this from the camera because that's where we're doing our pathfinding. It's a public list of vector2s. And then we're going to call this the path preview. And we're going to set that to a new list of vector2. Capitalize that L. Okay, so we have our path preview and our path line. And now we're going to go down. We're going to create a new function that's, again, going to be public. We're going to call this draw path. And in this, we're going to first grab our spline, which is the actual path, or the actual line that our sprite shape is following. So we'll call that the path spline, since that's what it is. And it's going to be the path line dot spline. We then want to clear that. So dot clear. So we will have no data points in it. And then the first thing we want to do is add in a position. Now the way we're actually going to draw this is as a shape from the actual unit itself. So we're going to set in a new vector2 of 0, 0 is what we're going to add. And we're going to call that pause for position. We're going to add that to the path spline. So we're going to use the insert points at because we want it to be where we need it. So we're going to add it to the end. So path spline dot get points counts. We're going to use that, and then we're going to put it in at put in our position. So 0, 0 to start, and then we're going to go through our path preview, and we're going to be subtracting its position from the previous data point's position. So we can then basically, instead of trying to draw a line on the exact coordinates, we're drawing it from the unit origin and then just drawing how that path changes. So from n equal to 1, so our first point above it, and less than path preview dot count, and just iterate up. Okay, so we're going to calculate a new vector2 called the direction is equal to the path preview at our current point minus the previous point. Okay, so we have our change in direction. So we're going to add that onto our position, plus equals direction, and then we're going to copy this line of code so we can insert that at our next data point. So we should have all of our splines set there. So we then need to, inside the path line, we're going to bake the collider. So that's going to actually ensure the data points are set. And then we have to make sure that the line is actually visible. So dot get component. And this is a sprite shape renderer. And we're going to call that, or we're going to call the color off that, and we're going to do a new color 32, and this is going to be 255, 255, 255, and around 150 should be pretty visible. Okay, so we have a way now to draw the path. So the next bit is going to be in our controls function. So what we want to do at this point, though, is we don't want to do this on the mouse button up. We want to be always doing this. So let's grab our position actually outside of our mouse button and just do it every frame. And then we are going to check if the unit is not equal to null. So we'll just copy this one and change it and then fix our brackets. So if we have a unit selected, we then want to check, or we want to draw the path of where we think it's going to go. Okay. So first, though, I only want to do this if we haven't given the unit a path to walk yet. So unit control.path.count. If it's less than or equal to 0, we know that it doesn't have a path. Actually, let's say less than or equal to 1, because its start position is going to be a path. And then we are going to want to actually try to generate a preview path. So we have to see, are we over top of a tile? So we have code down here for that. Now, we have to declare this, of course, as a raycast hit 2D. And now if we do hit a tile, we need to need to do our pathfinding to that tile. So we already have the code for that down here. So we can grab the position, do all that. Let's copy that, and let's put that up here in our hit, except instead of setting our path equal to this, we're going to set our path preview. We clear it. We don't need to set our current node and delay on this, and we are going to set the path preview to that. So this will show us the path it thinks it can take, and it's going to do that basically every frame we are currently have a unit selected. We set the path here, and then what we're going to want to do is we're going to want to make our preview invisible, because we don't want that walking with us. So we have our pathline component. So on this, we're going to get unit.getComponent unit control pathline, and then we set its new color. Now, one thing though, we have a unit. This is getting inefficient. We're constantly calling our unit control. So let's actually make another thing of unit control unit cont. So in that, we can now set when we select a unit. So here we can set unit cont is going to be equal to unit.getComponent unit control. We're just going to do this at the start when we select a unit. And then let's just copy that. And then the other place where we select a unit here. And now when we have a unit selected, we can then... So we're going to do a control F, and then we're going to just replace that with unit cont. And we have to do this one at a time so that we do it in the right spots. And then one thing I forgot, we then have to just set our unit control .draw path to make sure we actually are drawing it. Now we can be more efficient. We can check if the mouse has moved to a different tile. Only draw the path when it's actually moved. For now though, we're just going to leave it like this. You can add that in with all the way we've done, all the tutorials we've done. You should be able to figure that out. Alright, so let's go to our actual scout unit. So they're over here. Let's drag our path preview into the path line. Now with the path preview, we now, let's just make this invisible so that the player won't see it when the units spawn. And it should become visible when we actually select the unit. Okay, so let's grab a unit and let's see. So we are in fact drawing the path out, but we just have to set its visibility high enough, and there was a little glitch there. So let's go back into our scout and let's remember to grab our path preview. It's order and layer. Let's make that, let's put it above the unit. So let's make that 7. Let's try that out. Hit play on that. So when we click it, at first it doesn't do anything because we're hovering over ourself. And then we can click and it's drawing out the path. So when we get to the edge, it won't be able to do anything, but it will show sort of where it could have gone. Yeah, so look at that. We preview our path. If we move the camera around, we still draw it correctly again because we're only drawing it as differences in tile position from our unit, instead of trying to draw it at specific locations where each point in the spline is at a very specific location. Instead, we're drawing it from that unit. Now, we got a couple of things. So as I said, when we first clicked it, it doesn't have any data points, or it doesn't have a second data point, so it doesn't correctly erase the spline. So we're going to want to have it so when we select our unit, we run the draw path function right away before we even try to pathfind when we move the mouse. And then we have to make it invisible again when we deselect the unit. So let's go back into our tutorial scripts. So let's copy this, and then let's set this here when we select the unit, and again here. And now when we make it false, or this, the unit selection false, so down here we set the path line, sprite renderer color. This should be 0 on the alpha so that it goes away as the unit path finds. And then when we deselect a unit, So we can go here, and then again when we deselect a unit before we change it to a new one. So let's just separate those down before we swap it. Okay, so let's try this again, and let's see how that looks. Okay, so let's find a unit. There's one there. So, oh, it still had that bit of a glitch, but let's pathfind. The path preview should go away. So, as soon as I move my mouse off the tile, it should do that. You can see, though, when we get one where it wants to wrap, sometimes we're getting a couple little bugs there where there's no path found. So, you might have to fine-tune that. But for the most part, that is working nicely. Now, why it's visible before we have a path? So, let's do a little thing. So, we're going to check if path preview dot count is greater than 1. So when we actually have a path, we're going to draw it. Otherwise, we're just going to make it invisible. So let's copy the path line here, the color change into a 0. And actually that's a single thing here, so we can get rid of our extra brackets. Go back into our tutorial, and let's press play on that. So we select a unit, and we don't see any path. Now we do. He can't path anywhere because he's stuck in the corner. Let's select this one. We don't see a path. And then as soon as we actually have a path, it shows up. It goes away when we don't have a path. There we go. Look at that. So now we can preview our paths. You can see how the unit's going to move to whatever tile they want to go to. And then they'll start moving. And then we can select a new unit. We can get them moving. All right. So we have our path preview and unit movement working pretty nicely. Okay, so the last thing we can do is let's just generate some resources. And we're going to do this in a pretty simple way. There's nothing too fancy. We're just going to make it completely random. So in our art folder, I've already added in resources and split it into different things. Again, we just have some circles. My ideas are that this is like bronze, iron, gold, coal, and silver are sort of what I thought would be some resources you could have on the map. And so what we're going to want to do is we need to go into our hex resources. We're going to need to create a child object that is a resource. Let's go to our art. Let's drag one in. And then the resources are going to be order in layer 2. Remember, we have our hills, our order in layer 1, and then our trees, our order in layer 3. So let's make our resources order in layer 2. And again, we have to center, as with the others, we're going to center it on the tile. And we're going to make it invisible. Okay, so we're going to do this in a very similar way to the hills and trees, just with one extra thing. Instead of just being a bool for them, it's going to be an integer for the type of resource it is. So let's go to our hex type script. We're going to do here, so we're going to do a sprite renderer for our resources. Renderer resources is just going to be a public sprite renderer. And then we need a public integer called resource for whatever resource it is, and we're going to set it to -1. It will be -1 if there is no resource on the tile. And then we're going to do our similar thing as before, so we're going to do a public int old resource, also going to be equal to -1. Okay, so we have the same thing here. So if old forest does not equal forest type thing, if old hill does not equal old hill, let's copy this and let's do it for our resources. So if old resource does not equal a resource, so we don't want to just draw it. We also want to set our sprite. So if not a resource, if resource is less than 0, we make it invisible. Otherwise, instead of doing this, we're going to have a single color, the 255, so basically type 5 here. And then we are going to go back up here because I also realized we need, like with the hex, we need public sprite array of our resources. And then we'll call these res sprites. So each resource is going to be a sprite. And then what we can do, so we don't want hills.color here, we want resources. And then resources here. Let's actually change all these while we're sitting here. So old resource is going to be equal to resource after we change it. And then so the resources is dot sprite, since it's already a sprite shape, is going to be equal to the res sprites. And then in our brackets, we're going to put in the resource value. So again, this is going to be something greater than 0 or greater than -1 if we have a resource. So that will make it visible. Now the other thing we need, so old resource is going to be equal to resource -1. So that way, when we swap the type, we're going to change this just to make sure it goes through the code to redraw the resources. Okay, so we actually now need to generate them. Let's go back to our map maker. We are going to set in a new float. So public float resource frequency equal to 0. Let's say 0.1. So 10% of the map is going to be resources. Now in our mountains, we calculated our land area. We did that here with the count. Now instead of that, let's actually make that a parent variable. So we're going to just call that integer count here. We're going to set that to 0. And then let's get rid of our integer declaration in the add mountains. Because what we're going to want to do is we're going to want to figure out the number of resources based on the amount of land we have. More land, more resources. If you are doing, like, once you add in water resource, naval resources, you're going to want to change that up a little bit. But for now, we're going to keep this kind of simple. Okay, so under our draw grid, we are going to finally add in our resources before we do that. So draw grid is going to be a little complicated, but that's fine. So our total number of resources is going to be equal to, we're going to round it, so mathf.round to int. And what we're going to set that to is going to be our count, which is the number of land tiles we have. We just made that public, times our res frequency. That's going to be the number of resources we want to place. So we're going to use a number called current resource. This is going to be an integer that represents that the resource we want to change it to. We're going to track the number of resources we've actually placed, and we're going to track our number of attempts. So another while loop. We use tons of these. While loops are great. So if while place is less than or equal to our resource total, and our attempts is going to be less than 1,000, we're going to try enough attempts for this to happen. So we did a similar thing here. We calculated a random position, and we checked its hits. So let's copy all of this. Okay. So we have the hex already there. And then we are going to want to make sure it's not an ocean. Again, if you have resources that go in the ocean, you add another if statement and make sure that it's equal to 0. But we don't want to generate resources on our oceans and mountains. You might want to, and you can. But we're not going to in this version. Now, what we want to do is we want to set our resource. .resource is going to be equal to our current resource. And that should trigger our update function in the hex type here and make sure that this fires and the resource becomes visible. We know we've placed one, so now we need to swap to our other resources once in a while. And so we're going to start at the top of getting to our top resources. So we're going to make sure we set this as a float. So that's going to be our res total. So we're dividing how many we placed by how many we want to place, and then we're going to get the fraction of that. So the last resource, if we again look at our resources, what I decided was silver, coal, gold, iron, bronze. So we want gold to be the rarest, and bronze to be really common and more common than iron, and that type of idea. So we're going to check basically starting at the top. So we're going to make 20% of the resources we generate silver is going to be equal to 4, and then we go through our else ifs. So we need to make these else ifs so it only fires if it doesn't do the previous. You can use a switch case if you want, that's fine. I find this is just very easy to read. So resource 3 is going to be between 65% and 80%. Resource 2, which I believe is gold, so we want that pretty rare. But we can make that, say, 0.5 to 0.65. Actually, let's make that even rarer. And then we have resource 1 is our iron. We want iron to be pretty common, so let's make 25% of our resources equal to iron. And then 30% are going to be bronze, because we start with our 0 here. And now we can get rid of these integer declarations on the placed and attempt. Okay, so let's jump in. So back here, we need to go to our hexagon hex type script. So we need to set our resource sprites. We're going to have 5 different sprites. Again, you will, for however many resources you decide to generate, you can put them in as many as you need. So our starting 5 resources can go in. We have different resources. These are set to -1. And then, of course, we need to drag our resources over into our resources sprite renderer. And hopefully now it will work. And there we go. We have a pile of resources on the map. We generate different resources. Again, it's completely randomized at this point. These are the type of resources I think pretty much will generate randomly. Like iron is found all over the world. Coal is found in most parts of the world. And same thing with the other metals and everything. If you have resources that can only go on certain tiles, you can then, in your script where you're adding in those resources, so back in the map maker, you can have, in the function, you can be checking what is the tile type and make sure we only generate resources on that tile type of the resource that we want. Okay, and then the last thing we're going to do is we're going to just polish up this UI. So we now have resources. Let's add a slider in for it. So we'll call this resources, and then its name, where are we? We're here. Okay, and then we're going to name this sources, and then this is going to be our resource slider. Go back to our project there, and then its values, we're going to go from 0 for no resources to 0.2. 20% of the map can be there, and let's set 0.1 as our value, and then this can just be slid between 0 and 0.2. Okay, so let's grab all these and let's just move them up a little bit. And again, you can pretty up this UI later. You can make it look like whatever you want. And we got to go back to our script. In our map maker script, we now need to add in a resource slider into our slides. And then we need to remember when we're generating, or when we're grabbing this, we just need the res frequency is equal to the res slide.value. And this way, again, in our generator, we can now set the resource frequency. So we need to go to our camera, as with before, and then grab our resource slider, drag it on over into our inspector here in our map maker script, give that a little save, and let's run it. Okay, so our default value generated, we turn resources up, confirm, and we have a lot of resources on the map. We turn it down, hit confirm, and we have none. All right, so we now have our pathfinding preview done. We have resources being able to generate. We have a UI that can change up all of our different values and has some presets in it. So you could use that when you are, or when you have your players generate their game and their map. So that's actually all I have for this tutorial series at this point. I'm going to think of features to be doing in the future. I want to code in Fog of War. I want to code in other interfaces in that. But it'll be a while before the next tutorial episode since I haven't done any of that yet. And I also want to get back to working on Dungeon Maker and doing some more updates to it. So if you have any ideas on what you would like to see a tutorial on in a strategy map game and different things you want me to try to figure out how to do and then make a tutorial on, please let me know in the comments. If you made it this far in the tutorial series and watched every episode, thank you very much for watching this and supporting me. And I hope you all learned something and have created some really interesting maps. If you've been using this in a game you're making, please link it and let me see what you're working on so I can see how you've been able to apply this tutorial to your work and the different games you're applying it to. I would absolutely love to see that. And as always, have a good one.